In the previous video, we looked at how we can go through and use the rational zeros theorem to find the possible rational zeros for a polynomial function. In this video, what we're going to do is we're going to kind of follow up on that. And what we're going to do is we're going to use something called the factor theorem. Okay, you might remember that from the previous video. And the factor theorem says, remember, that if we have a value c, so we have f at c, and sorry, not sure what's going on with my pen here. So if f at c equals 0, then x equals c is a 0, and x minus c is a factor. Okay, so we can use that to be able to help us to be able to factor a polynomial function that might be of a degree higher than 2, and usually we can factor ones of 2 without much difficulty. So we're going to use that in conjunction with some of our polynomial long division, okay, or synthetic division, and then we're going to be able to find the zeros of a polynomial function. Okay, so in these examples for these functions, we're going to find all the rational zeros. We're going to use the factor theorem, and then we're going to divide the polynomial using mostly synthetic division. And then if for some reason we can't factor the remaining polynomial, we'll just use the same process again. Okay, so we want to find all the zeros of the polynomial function without a calculator. Right, so we have x cubed plus 2x squared minus 5x minus 6. So we know that p in this case is going to be -6 and q is going to be 1. And we know the factors of 6 are going to be plus minus 1, plus minus 2, plus minus 3, plus minus 6. And we know the factors of 1 are plus minus 1. And the good news is whenever we have 1, we just use the original factors of p, because dividing everything, remember we do p divided by q, or we take p divided by q. And if we do that, the possible rational zeros, so possible rational zeros, will be plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Okay, now our job, and this is part A for this, our job is to be able to find one of those values that when we plug it in for f, we get 0 out of it. Okay, so now I always try to start with the easier ones. Okay, so start with 1 or -1 or something like that and see what happens. Okay, so for part B, okay, we're going to say f at 1 is going to be 1 cubed plus 2 times 1 minus 5 times 1 minus 6. And if we compute that, that's going to be 3 minus 11, which is -8. Okay, so we know that 1 is not a 0. Okay. Let's try f at 2. Okay, so f at 2 is going to be 2 to the third plus 2 times 2 squared minus 5 times 2 minus 6. Okay, and I think this works because this is going to be 8. This is going to be 8 minus 10. Okay, so that would be 16 minus 10, which is 6, minus 6 is equal to 0. Okay, so that's good because that means we can move on. All right, so now what we're going to do is we're going to say that x equals 2 is a 0. Okay, so that's one of our solutions. But even more importantly, x minus 2 is a factor. Okay, so that's important to us. Okay, now what we're going to do is we're going to use polynomial division to be able to simplify or to be able to factor this. Okay, so for step 3, or for part C, we're going to take our 2, which is our 0, and we're just going to use synthetic division. Our coefficients of this polynomial are going to be 1, 2, -5, -6. Remember, since it's a factor, the remainder should be 0. So we're going to bring down the 1. We get a 2 and a 4. We get an 8. That's a 3. 2 times 3 is going to give us 6. -6 minus 6, or -6 plus 6 is 0. And that's good. And remember, this is the constant. This is our x, and this is our x squared. Okay, so the resulting polynomial from this division is going to be x squared plus 4x plus 3. And this is another factor, okay? So if we take our two factors, we take our x plus 2 and our x squared plus 4x plus 3, now what we can say is that the function f of x is going to be equal to x minus 2, which we said was a factor, and the quotient is the other factor, x squared plus 4x plus 3. Finally, what we can do is we can now factor this trinomial pretty easily, and that's just going to be x plus 3, x plus 1. All right. And so now what we can do is we can easily find the zeros of the polynomial function because it's completely factored, okay? So, and again, we didn't have to repeat this because we only had a third degree polynomial. Usually what we do is we just repeat this until we get to a quadratic, and we know how to work with quadratics, okay? So finally, what we're going to do is we're just going to set each of these to 0. So we're going to set each of the factors to 0. So we're going to say x minus 2 is 0, x plus 3 is 0, and x plus 1 is 0. All right, and so it gives us our three solutions. X is 2, x is negative 3, and x is negative 1. And so those are our three solutions. Now, I want you to notice a couple things, okay? So first of all, negative 3 and negative 1 were part of those possible rational zeros. So we had negative 3 and negative 1. We just didn't pick those, right? We used the easy ones, we used the positive numbers. However, if we used negative 1, that would have given us a 0, okay? If we used negative 3, that would have given us a 0. So a check might be, at the end, you take a look at the rational zeros, they should be part of that list. And if they're not, that means you should go back and try to redo the list, or maybe you just factored something incorrectly. Also, what this means is that 2, 0, negative 3, 0, and negative 1, 0 are intercepts. Okay, in fact, they're x-intercepts. And if we graph it, we should be able to see these on the graph. Okay, so let me go ahead and use our calculator. So Desmos graphing calculator. All right, and let me go ahead and graph the original function, then we can be done with this video. So we have our x cubed. So we have y equals x cubed plus 2x squared minus 5x minus 6. All right. And if I zoom out a little bit, I wonder if I copied that down wrong. X cubed, 2x squared minus 5x minus 6. Oh, that's y. There we go. I want you to notice that what we have is we have three intercepts. Remember, we have negative 3, 0. Okay, so that's one of our intercepts. It's precisely that. And then we have negative 1, 0. And if we look at the graph, it's precisely that. And then the one that we found using the rational zeros theorem was 2, 0. Okay. Now, I didn't ask you to find the y-intercept, but clearly that would be negative 6, 0. And we could find that pretty easily. Right? So this is how we can take some of our higher order polynomials that we can't factor right away. I want you to notice that looking at this, we couldn't factor this polynomial immediately. Okay, we would have to use a rational zeros theorem to try to factor it to put it into this form. So it's not an easily factorable polynomial like the ones that we looked at a few sections ago. Right, so in subsequent videos, we're going to take a look at a few more examples of this rational zeros theorem to be able to factor our polynomials, but also to be able to find the zeros of those polynomials.